welcome to EC Electronics. Today's video we are going to see the previous year questions of Technical Assistant examination for the center URSC, that is URSC Center, Bangalore. Okay, so we'll be seeing the questions from 2017 Technical Assistant examination of URSC Center, that is URSC. Okay, so let us see what is the first question. Battery cells are connected in series to dash. Battery cells are connected in series. We know that if you connect battery cells together in series, it will be like this. Like this, we are going to connect the battery cells together in series. And if these battery cells are connected together in series, the output voltage will get increased. Because we know that this battery will provide a constant DC voltage. Right. So when these cells are connected together, its output voltage will increase. So when cells are connected in series, the total voltage will be the sum of each voltages or individual voltages. So hence the output voltage will get increased if we connect these voltages or batteries in series. So they are connected in series to increase the output voltage is the answer. Moving on to the next question. So these questions are very much simple or direct questions. Some questions are problematic questions, but even then the answer is not confusing or the options is not confusing. That's why I have not included all those options. Okay. So moving on to the next question. The value of alternating current or voltage that has the same value having the value of alternating current or voltage that has the same heating effect as a corresponding DC value is called dash. It is called RMS value. Okay. So what is RMS value? RMS value is a DC value or a constant value corresponding to a alternating current or a voltage whose having the same effects as that of the alternating current or voltage. That is a constant DC value which is giving the same effects as that of the alternating current or voltage is called its corresponding RMS value. That is this alternating currents or voltages RMS value. It is a DC or a constant value. Okay, and the RMS value, if the peak value is given to you, I'll remove this little bit. Okay, so if Vp is the peak value, then the RMS value is given by Vp by root 2. Okay, so that is the equation for finding the RMS value. If Vp is the peak voltage, then Vp by root 2 is the RMS value. Moving on to the next question. Let me make some space. Going on to the next question. If the number of turns in a coil is doubled in the same length and area, the inductance is dash. That is, if the area and length is kept as constant and the number of turns is doubled, how will the inductance change? That is a question. So the equation for inductance is given by N is equal to, inductance L is equal to N square mu into A by L. This is a small letter L, where N is the number of turns, mu is the permeability of the material, A is the area, L is the length of the wire. So inductance L is given by, in terms of the properties of the material or the conductor, you can write this as L is equal to N square, where N is the number of turns, mu is the permeability, A is the area, L is the length. Now, if this N has been doubled, what will happen? You can write L dash is equal to 2N the whole square mu A by L will be the new inductance, right? So 2 square is 4. So you can write 4 times N square mu A by L, or you can write L dash is equal to 4 times L. So how much will be the change? It will get quadrupled, or it will be 4 times the previous value. That is, if the number of turns is made as double, then the inductance will be increasing by 4 times. So you have to choose from the options. It has to quadruple. Okay, that is the answer. Moving on to the next question. If a sine wave has time period of 40 microseconds, its frequency is dash. Very simple question. The time period is given. You need to find the frequency. Frequency is equal to 1 by time period. So just take the reciprocal of this 1 by 40 microseconds, you will be getting 25 kilohertz will be the frequency. If you take 1 by 40 microseconds, the answer is 25 kilohertz is the frequency of a sine wave which is having period of 40 microseconds. So this type of very simple, but you have to know the basic things. Questions you can expect. Okay. Next question. A capacitor that can store 100 microcoulombs of charge with 10 volt across its plates has capacitance dash. Okay, so this is a capacitance problem. There is a capacitor which can store 100 microcoulombs of charge. That is Q, it can store 100 microcoulombs. Voltage V across these plates is given by 10 volt. Okay, so you need to find what is the capacitance. What is the capacitance value? So the equation is a very basic equation generally we use for capacitance. Q is equal to CV. From this, C is equal to Q by V, which is equal to 100 microcoulomb by V is 10. So you will get 10 microfarads. Okay. So the answer coming is C is equal to 10 microfarads is the answer. So the capacitance value is 10 microfarads. So the equation you have to use here is this, which is a charge equation. Charge that is getting stored in the capacitor is given by capacitance into the voltage across the plates of the capacitor. Moving on to the next question. How much resistance must be connected in parallel to 360 ohm to get REQ, means equivalent resistance of 120 ohm. So this is a very simple parallel connection of two resistors. Okay. That is, two resistors are connected in parallel here. This is one resistance, this is another one. So there are two resistors connected in parallel, out of which one is 360 ohm. We need to find this. Let it be X. Okay. So the equivalent of this circuit, REQ, is given by 120 ohms. So you need to find what is the value of X. That is a question. So what is the equation for finding REQ? You can write the relation as 1 by REQ is equal to 1 by 360. This is a parallel combination or connection. So 1 by REQ is equal to 1 by 360 plus 1 by X. So REQ is nothing but 120 ohms. So we can remove this ohm value or ohm unit. So from this you need to find 1 by X is equal to 1 by 120 minus 1 by 360. So the answer is 1 by 180 is the answer coming. So X is equal to 180 ohms is the value. So X is 180 ohms if you have to get a equivalent resistance of 120 ohm. Okay. So the answer is you have to connect 180 ohm in parallel with 360 to get an equivalent of 120. Okay. So this is how you do these problems. This type of problems also I have seen in various question papers. So just have an idea of how to apply or how to approach this type of problems. You will be given the equivalent value. And one value of the combination will be given. You have to find the other value. Just apply the parallel equation. Okay. Anyway, the correct answer coming is 180 ohms here. The next set of questions is this. A differential amplifier has AD, which is differential mode gain 100, AC common mode gain of 0.1. Find CMRR in dB. Okay. So first we will find what is the CMRR value in a ratio. Then we will convert that to dB. So what is CMRR? CMRR is common mode rejection ratio. That is the ability of the op-amp or a differential amplifier to reject common mode signals. And it is given by differential mode gain by common mode gain. That is 100 by 0.1 is a AC here. And you will get it as 1000. Okay. So CMRR is 1000 or 10 raised to 3 is the CMRR, but we need to find the value in dB because the options were given in dB. Okay, so the relation here we have obtained is 10 raised to 3. We need to find the value in dB. So CMRR in dB is given by the relation equal to 20 log 10 CMRR in ratio. So this value is in ratio. You need to find that value in dB. So just take 20 log 10, 10 raised to 3 is a value that we have obtained here. So if you take it, you will get 3 into 20 into 1. That is 3 into 20 is 60. So you'll get the answer is 60 dB is the CMRR for this particular differential amplifier, which is having differential gain 100 and common mode gain is 0.5. Okay, so the answer is 60 dB. Moving on to the next question. What is the modulation index in an FM, that is in frequency modulated system, with modulating frequency of 500 Hz and frequency deviation of 10 kHz? First, let us look the equation for finding the modulating index. Modulating index M for a frequency modulated system, that is an FM system, is given by maximum frequency deviation by modulating frequency. Sometimes this maximum frequency deviation can be also taken as bandwidth. Okay, so this is the relation for finding modulating index. Here both these values are being given. Maximum frequency deviation is also given and modulating frequency is also given. So directly substitute and find the value of modulating index. Okay, so what is maximum frequency deviation? It is 10 kilohertz. 10 kilohertz by modulating frequency is 500. Okay, so the answer obtaining is 20 is the modulating index for this system with maximum frequency deviation or frequency deviation is 10 kilohertz and modulating frequency is 500 Hz. So use this relation that M, modulating index M, is equal to frequency deviation by modulating frequency. Okay, so the answer obtaining is 20. Next question, notch filter is a dash. Notch filter is a band stop filter. So there are various types of filters. We'll discuss that in brief. So there are various types of filters. There is low pass filter. The low pass filter will pass only lower frequencies and it will cut off all the higher frequencies. So the curve or the frequency cara will be like this. For lower frequencies it will be present and for higher frequencies it will cut off. So it will go down like this. Now for high pass filter, it will be in the reverse form. That is, it will not pass lower frequencies, it will pass only higher frequencies. So it will go like this. Now there is band pass filter. So this will only pass a certain band. So the cara will look like this. Now band stop filter is the next category. I'm just drawing graph figures. Okay. So it will pass certain frequencies, but it will stop. See, there is a stop band in between the pass bands. Okay. So it will look like this. This is the stopping portions, or this portions it will not pass. So that is called band stop filters. These areas it will not pass. So they are called band stop filters. Now these band stop filters with a very smaller stop band, that is, if this area or if this duration is very small, it's looking like a notch, then it is called a notch filter. Okay, so these band stop filters with very small stop band or band which is not passing, if this portion is very narrow, then it is called a notch filter. Okay, so you can call this notch filters are actually band stop filters. Okay, moving on to the next question. What is the barrier potential of silicon diode at room temperature? Very basic question. We have been using this through all our problems while considering the diodes. Normally we use silicon diodes only. So the silicon diodes are having a barrier potential or built-in potential or threshold voltage is equal to, all these terms we use sometimes, is called 0.7 volt at room temperature for silicon. For germanium it is 0.3 volt. Okay. Which diode is used? Use this voltage regulator. The options were pin diode, Zener diode, photodiode. So these were the various options, overactor diode, etc. We know that Generally, Zener diodes are used as voltage regulators. We have done 2 separate videos for Zener diodes. So, we generally use Zener diodes as voltage regulators. Okay. Next question. The main advantage of CMOS is its dash. The main or the major advantage of CMOS is that it is having only very low power consumption. The other advantages are it is having a very high resistance towards noise. That is, it is having a very high input resistance. Okay, so these are the main features that why we go for CMOS or complementary metal oxide semiconductor configurations or connections. Okay, so the main advantage is that it is having very low power consumption. Next question. SCR is normally turned on by gate triggering. So we have discussed this in one of the previous videos. There are various methods to turn on a SCR. It is forward voltage triggering, DV/DT triggering, light triggering, thermal triggering, gate triggering. These are the various ways we can turn on a silicon control rectifier. But out of this, the most commonly used method is gate triggering, or by applying a current or a current pulse to the gate. Okay, so I have done a separate video on SCR, how to turn on the SCR, what is a CARA, what are the main features, what are the terminals. I'll share the link in the description box. Okay. Next question is a very simple, common type of questions. Sphygmomanometer is used for dash. Okay. This is something related to general awareness, or it can come in the biomedical section. Sphygmomanometer is used for measuring of blood pressure. Okay. For checking of blood pressure, we use sphygmomanometer. The instrument is called sphygmomanometer. Next question. Ultrasonic diagnostic imaging typically employs a frequency range from 1 megahertz to 15 megahertz. So for ultrasonic imaging or diagnostic imaging, the frequency range of usage is 1 megahertz to 15 megahertz. Next question. These are not very they come under general knowledge type or area. Okay. Persistence of vision in human eye duration is dash. So what is persistence of vision? We know that when we look at an object, or when there is an image in front of the eye, this image will last for 1/16th of the, I'm already saying the answer, 1/16th of a second, even if we are out or we have moved our eye from that image. That is, the image will last in the brain actually. Okay. So this is actually an inertia of imaging. That is, whenever we are seeing something, this image will last in our brain for 1/16th of a second, even after we are not seeing that image. Okay, or it has been removed from in front of the eye. So this property is called persistence of vision, and the duration is 1/16th of a second. It will last. Okay. Transconductance in a FET, that is field effect transistor, indicate how effectively the input voltage controls the dash. Transconductance, I'll write the equation first, then I'll answer the question. GM is equal to dI by dE or dV, where dV is the voltage applied on the gate, which is the input voltage. dI is the drain current, which is the output current. Okay. So if you know this equation for transconductance, you can answer this question. I'll read out the question once again. Transconductance in a FET indicate how effectively input voltage controls the output current. Okay, the answer is output current. So this relation or this connection between this output current and input voltage is represented like this using transconductance, where GM is equal to dI by dV. Moving on to the next question, aspect ratio of HDTV. So this is coming under the TV subject. Aspect ratio of HDTV is 16:9 is the aspect ratio. Next question, as compared to SCR, LED has a dash. So if you compare LED with SCR, LED is having a higher forward voltage, higher forward conducting voltage, and lower breakdown voltage. Okay, that is the case for a LED. It is having a higher forward conducting voltage and lower breakdown voltage. That is, it will get breakdown at a lesser voltage than SCR, but in order to turn it on or in order to have a forward conduction, it requires more voltage. Okay, so that is the case for a LED as compared to SCR. So these are the questions that I have included in this video. I have included 20 questions in this video from URSC Technical Assistant question paper of 2017. So if you are preparing for any of the Technical Assistant examinations which is going to happen very soon, that is HSFC is there, SDSC is there, VSSC is there, SAC is there, IPRC is there, URSC is there. So there is a lot of examinations on Technical Assistant especially going to happen from ISRO for various locations. So if you are preparing for any of these areas, these question paper discussion will be very much useful for you. So if you found this useful, please do give it a thumbs up and try to share this videos with maximum of friends who is preparing for any of the Technical Assistant examinations. Okay. And if you found this video useful, please do subscribe to the channel and keep on watching, and thanks for watching.